All right, fill in the box to make the equation true. So negative 3 plus something gives us 12. So let's see. If I'm at negative 3, and here's 0, and I want to go all the way to 12. Now let's see. Here I have to add 3, and then there I have to add 12. So that's total is 15. So negative 3 plus 15 gives me 12. 3 plus something equals negative 1. So let's look here. 3 plus something. So I'm at 3, here's 0, and I want to go to negative 1. So I have to add something negative. So plus a negative, let's see, 3 to get to 0, and then 1. So negative 4. 3 plus something equals positive 1. So for that, here's 1, here's 3. I have to add a negative 1 too. Negative 3 plus something equals negative 7. So here's negative 3, here's negative 7, negative 4, negative 5, negative 6. So I have to add a negative 1, 2, 3, 4. Three minus something equals 7. So remember, subtraction is the same thing as adding the opposite. So it would be 3 minus, well, to get to 7, I know that 3 plus 4 equals 7. But I want to do minus, so it has to be minus negative 4. So it becomes 3 plus positive 4. Negative 3 minus 4 equals 7. Negative 7. 56 divided by 7 gives us 8. Here we've got something times y divided by 5 equals y. So we're going to multiply 5 times y divided by 5, because then the 5's cancel out and we're just left with y. Here we've got 3ab, and we simplify and we just make a over 3. So we've got to have a b on the bottom, so the b's cancel out, and then we're going to have a 9. Because when we simplify, we get 3, we divide by 3, and we're left with 3, and then a. Complete the following fraction calculations. So first thing we need to do for addition, we want our pieces to be the same size, so we have to get a common denominator. We'll do that by multiplying this one by 2. So we get negative 4 sixths plus 7 sixths. Negative 4 plus 7 gives us 3 sixths, which is 1/2. Same thing here. So we get 2/4 minus negative 1/4. Subtraction is adding the opposite, so plus positive 1/4 gives us 3/4. Remember, when we multiply fractions, we multiply numerator and then denominator. 2 times 3 is 6, so we've got negative 6 over 5 times 4 is 20. We can divide both sides by 2, so we get negative 3 over 10. I remember when we divide fractions, we have to take the reciprocal and multiply. So we get 6 over 7 times 7 over 2. That gives us 6 times 7 is 42 over 7 times 2 is 14. We can divide each by 2, so we get 21 over 7. 21 divided by 7 is 3. 100 divided by 0 is undefined. We cannot divide a number by 0. 0 divided by any number is just 0. Solve the following equations and show your steps clearly. So x plus 3 equals 7, so we have to subtract 3 from both sides. So we get x equals 4. 2x minus 4 equals 8. So we're going to add 4 to both sides. We get 2x equals 12. Then divide by 2. X equals 6. Here we have negative 3x times negative 3 times x equals 15. So we divide by negative 3 on both sides. X equals 15 divided by negative 3 is negative 5. Write the coordinates of each point A through F in x, y form. So A is, let's see, negative 1, 2, 3, 4, 5, and y is 1, 2, 3. So negative 5, 3. Remember to put the parentheses. Like that's standard notation, is to have the parentheses around the coordinate points. B is x, 1, 2, 3, and y is 1, 2, 3, 4. C, x is 2, y is negative 1. D, let's see, x is 1, 2, 3, y is negative 1, 2, 3, 4, 5. E, x is negative 1, 2, 3, and y is negative 1, 2, 3, 4. And F, x is negative 2, and y is positive 1. Now label the following points on the coordinate plane. So G is 3, 2, so I go to the right 1, 2, 3, and up 1, 2. So that's G. H is 1 over 1 and up 4. X equals negative 2. Y is negative 1. J, x is 1, 2, 3, 4, and y is negative 2. And K, x is negative 5, and y is 1. Examine the tile pattern below. Draw figures 0, 1, and 5. So let's see, what do I notice? I notice that this keeps getting bigger. So here we have, I notice that this stays the same in every picture. I notice that figure 2 has a rectangle that's 2 by 3. Figure 3 has a rectangle that's 2 by 4. Figure 4 has a rectangle that's 2 by 1, 2, 3, 4, 5. And then these are also getting bigger. So that's 1, 2, 3. So let's see, figure 1. The parts that are adding, let's see. This is adding, that's adding, this is adding, this is adding. So that was added. So figure 1 would look like that, because we take away this one and we take away these two. So then figure 0, let's see, we take away this one and we take away those two, so we're just left with 2. Figure 5 would look like, let's see, it'd have this long skinny part that has, let's see, 1, 2, 3, so it'd have 4 here. Then it'd have the rectangle, and it has 5 here, so this one will have 6, so it has 4 and then 6. 1, 2, 3, 4, 5, 6. And then it would have 1 right there. make a table that tells you how many tiles are in each figure. So figure number and number of tiles. So figure number 0 has 2. Figure number 1 has 1, 2, 3, 4, 5. 2 has 6, 7, 8. 3 has 8, 9, 10, 11. And I notice that I'm adding by 3 each time. So figure 4 is going to have 14. Figure 5 is going to have 17. How many tiles would the 10th figure have? So there's different ways you could do this. I'm just going to keep the table going. 6, 7, 8, 9, 10. So this would be 20, 23, 26, 29, 32. We could also draw it. So we know that it's going to have this long skinny part, and then it's going to have this long rectangle right here, and it's going to have 1 right there. So I noticed that this long skinny rectangle has, the figure number 3 has 4, 4 has 5, 5 has 6, so this is going to have 11. And then this other rectangle right here, figure 5 has 4, figure 4 has 3, figure 3 has 2, so it's 1 less than the figure number. So figure 10 would have 9. So if we have 9 here, 11, 11, and then 1. 11 plus 11 is 22 plus 9 plus 1. 22 plus 9 gives us 31 plus 1, which is 32, which matches our table.